Hi everyone, welcome to the Splunk4Rookies Observability Cloud workshop. I'm glad to see everyone here. We're going to take some time to let everyone filter in, and we'll get started at around 12:05. Thank you for coming. I hope you guys learn a lot and that you can bring back some valuable information for your companies. If you're not able to find the login email to the Splunk Observability Cloud interface, please drop in your email to the Q&A box and our support team will resend it to you. It should start the email subject with things just Splunk Observability Cloud, and check your spam as well as your junk email folders in case it went into there. Okay, thank you, Ishal, for dropping in your email. We'll take care of you real soon. If you're not able to see or hear me very well, please turn off your VPN. That would help a lot in terms of the presentation quality. If you've gotten an email beyond the login email, in it should contain the lab guide, which is a splunk.github.io URL. If you fall behind on the workshop or want to look back on it, this is a publicly available URL, so you can look back on it and redo things, or look at the screenshots. So I will be following that lab guide verbatim today, and you won't miss anything if you fall behind. Other links in there include a online boutique link to an e-commerce website. We're going to be doing some live transactions there, so you can view your details right in Splunk Ollie. So just to clarify, that online boutique is not the public instance. So this is different than Splunk Enterprise. There's no instances here at all whatsoever. So that doesn't have to be in your vocabulary. It'll just be logging into a UI. It will be making dashboards and observability details from there. So when you receive the login email, you'll have to create your own username and password. And that would be your login info for this workshop. You're making your own password. So everyone should be making your own username and password for SignalFX. Just to clarify that Ollie for Rookies URL is not the public instance link. It's just an e-commerce link for a website that we'll be doing transactions on. There is no instance that we'll be logging into today. If you can't hear or see, please turn off your VPN. You make your own password, Yushi. Yep. Once you are logged in there and you see something like this, you're good to go. Just sit tight right there. Okay, well, I'm going to get started. The chat support team will help all those who need some login help. And everything is available online at the Splunk GitHub IO URL. So you can follow along at your own pace. So let's get moving. So welcome again to the Splunk4Rookies workshop. It's been a while since we had one of these, so thank you for this great interest. Just some standard forward-looking statements. Everything here that we're demoing is what is most current as of now. So next week or in a couple of months, when you check back on the UI, you see something completely different. It just means we're turning on new features all the time. And also a small caveat is our lab guide and our demo UI for today sometimes don't match up exactly because documentation does take some time to update as the UI is updated. So if you can't find something exactly as listed in the lab guide, use your creativity or your imagination and we can troubleshoot a bit to find the correct button or link. I have caught some, so I will make note of that as we go through the lab, but I just want to make that clear before we get started. A little bit about myself. My name is Kathy Yu, and I've been at Splunk/Cisco for about a year. I was a software engineer for about 8 years prior to this. So I've sat where you guys have, troubleshooting a lot of war room things. I was a React, Angular, and let's see, mobile developer for that time. But we also did a lot of DevOps and backend work with Node.js. And GraphQL. And during that time, I used Datadog, New Relic, and Splunk. And from those 8 years, I still enjoy Splunk above all those three tools. So now that I'm on the Splunk side and sharing and talking about it, it's kind of fun and exciting because I've sat where you guys are, and I'm really excited to demo and show how it can make your lives easier. So this is your chat support. We have Gabby, Jesse, and Matthew. We did not get a picture from Matthew, so that is definitely a guy there. They will be helping you out in chat support with any issues and questions. I highly recommend putting questions into the Q&A box to separate from the attendee chat. That way we can get to you more quickly. So during this time when I'll be presenting, I won't be looking at those two chats there as I need to focus on presenting, but these three people will be helping you out here. Some quick logistics to go over. So there's about 10 modules that we'll be going through, and I will read the lab guide and we'll go through the exercises. What will be most helpful to you learning is before each exercise, I will give you about 5 to 10 minutes to complete them, but on the screen as I'm sharing, I will be doing them with you just at a bit of a faster rate. So then you can see exactly what I'm doing and copy if you need to. But if you don't get it, that's totally fine. The lab guide is still public, and you can go through it on your own. Some small caveats as I'm demoing is observability is a very, very long word. So I might use Ollie for short. It's very similar to like accessibility, that kind of shortening of the word. And this is about a 2.5 hour to 3 hour long workshop, but I'll give you about 5 to 10 minutes of breaks between every section to do a bio break or get some coffee. Once you log into the interface, there will be a constantly used workshop app or test name called Ollie4Rookies. So whenever in your lab guide you see something that says like bracket, workshop name, bracket, app name, Ollie4Rookies will be that. And I'll continually remind you. So if the interface doesn't look exactly like the lab guide, that's what you're looking for. And finally, if you run into any connection issues, please turn off your VPNs. Can't guarantee it'll make it better, but it's highly recommended to do so. Let me see. Anything else? I will have some time at the end for questions. Just depends on how fast we can get through this workshop. And I'll just enter them straight from the Q&A chat there. All right, so today's agenda, we'll go through what is observability, introduction to it, and we have a bunch of hands-on exercises. So that online boutique website that you saw, which is not the instance, it's just an e-commerce website, we're going to be doing some test transactions on there so that we can debug it using RUM, which is real user monitoring, EPM, which is application performance monitoring, Log Observer Connect, which is logs. And if you have used Splunk Enterprise before, Log Observer Connect is a direct replica of that, except in a more of a milder, lesser fancy UI. We'll also do synthetics, and then we will create our first dashboard so we can monitor our online boutique website. And then we'll wrap up with some resources. Right. So now I'm going to move on to the lab guide. Give me a second. All right, so we'll have a bit more time to log in, but this will be what the Splunk Observability Cloud interface looks like. There is no instance or terminal you need to log in compared to Splunk Enterprise, which is really nice. So just a quick overview of this workshop. The goal of this workshop is to give you a hands-on experience troubleshooting an issue in Splunk Observability Cloud to identify its root cause. We provided a fully instrumented microservices-based application running on Kubernetes, which sends metrics, trace, and logs to Splunk Observability Cloud for real-time analysis. This workshop is ideal for anyone looking to gain practical knowledge of Splunk Observability and is designed for individuals with little or no prior experience with the platform. All you need is your laptop and a browser with access to external websites. And this workshop can be attended either in person or via Zoom, or WebEx. And I believe that this session is recorded. In this 3-hour session, we'll be going over a couple of fundamentals. Splunk Observability is the only platform offering streaming analytics and no sample full fidelity distributed tracing. This is what you can expect today. Open telemetry. We can learn how open telemetry is essential for modern observability and how it enhances visibility into your systems. We'll take a tour of this UI here, everything from APM to run, log observer infrastructure, and logs. We're also going to generate real user data on this part here. So if you can see this website right here, some of the real user data that will be generated will be simply clicking on some items, adding them to a cart, and checking out. And then we're going to see these real time in the Splunk Ollie interface. We'll also work with Splunk Real User Monitoring and analyze the full user data collected from your browser sessions. And today's task is to identify poorly performing sessions and begin the troubleshooting process. Splunk Application Performance Monitoring. This is one of our favorites here. You can gain end-to-end visibility by linking a run trace, which is for the front end, to an APM trace, which is the back end. And you'll explore how telemetry from various services is captured and visualized in Splunk Ollie Cloud, helping you detect anomalies and alerts. Next, we'll go to Log Observer Connect, and we'll be able to use the related content feature to easily navigate between components. And this will help a lot in terms of digging through logs, which I'm sure you guys are all familiar with, and narrowing it down to the essential ones to do root cause analysis. And finally, there are Splunk Synthetics right here. Synthetics can help with the 24/7 monitoring of your application. It's almost like a bot user that tests all of your clicks and APIs and browsers and ports before the real users get to them. And we'll walk you through setting up a simple synthetics test that runs every minute to monitor the performance and ability of the online boutique website. So by the end of this session, you'll have gained practical experience with Splunk Observability Cloud and a solid understanding of how to troubleshoot and resolve issues across your application stack. Okay, so going back to here. Yeah, there we go. So what is OpenTelemetry and why should you care? So OpenTelemetry is what Splunk Observability is built on. With the rise of cloud computing, microservice architecture, and ever more complex business requirements, the need for observability has never been greater. Observability is the ability to understand the internal state of a system by examining its outputs. In the context of software, this means being able to understand the internal state of a system by examining its telemetry data, which includes metrics, traces, and logs. To make a system observable, it must be instrumented. That is, the code must emit traces, metrics, and logs. The instrumented data must then be sent to an observability backend such as Splunk Ollie Cloud. OpenTelemetry does two important things. It allows you to own the data that you generate rather than be stuck with a proprietary data format or tool. And it allows you to learn a single set of APIs and conventions. These two things combined enable teams and organizations the flexibility they need in today's modern computing world. There are a lot of variables to consider when getting started with observability, including the all-important question, how do I get my data into an observability tool? The industry-wide adoption of OpenTelemetry makes this question easier to answer than ever. So why should you care about this open source third-party system? OpenTelemetry is completely open source and free to use. In the past, monitoring and observability tools relied heavily on proprietary agents, meaning that the effort required to change or set up additional tooling required a large amount of changes across systems, from the infrastructure level to the application level. Since OpenTelemetry is vendor neutral and supported by many industry leaders in the observability space, adopters can switch between supported observability tools at any time with minor changes to their instrumentation. This saves a lot of time, especially as a developer. This is true regardless of which distribution of OpenTelemetry is used. Like with Linux, the various distribution bundle settings and add-ons, but are all fundamentally based on the community-driven OpenTelemetry project. Splunk has fully committed to OpenTelemetry so that our customers can collect and use all the data in any type, any structure, from any source on any scale, and all in real time. OpenTelemetry is fundamentally changing the monitoring landscape, enabling IT and DevOps teams to bring data into every question and every action. You'll experience this during these workshops. Okay, so if you're in the lab guide, which is the with the URL Splunk github.io, we're going to go to number 3, which says UI-quick tour. So we're going to do a quick tour of the basic tools we're going to use before we dive into actually debugging on this interface with the transactions of Online Boutique. So we will get started with the short walkthrough of the various components. So you should have received an email from Splunk inviting you to the workshop org, and the email will look like something like this screenshot here below. And you have like a unique login and token here. So go ahead and click on that Join Now button, and you're going to log in either from the Ameri side, which is the American side, or the EMEA side, which is the European side. And as you make your password, make sure it's unique and long and easy to get into. So again, this is different than Splunk Enterprise in that you create your own password. You don't have any instance details given to you. So go ahead and do that and sign in, and you should see this as your home page when you come in with your own name and everything. All right, so here is your homepage that you'll land on. A quick walkthrough. This is now 1.1 on the lab guide. You can expand and contract this menu here to save on space on your screen. There's also an org switcher on the top right-hand corner. So if you tap on that and you go to organization, please ensure that you're in the observability workshop organization. Otherwise, you won't be able to see all the things that I'm seeing. So click on that to make sure. In this corner right here, there are teams. If you're using this in real life, you might have multiple teams you're on. But for today, we're all going to be in the Splunk4Rookies team and be viewing things from there. Finally, there is this panel here of active alerts. So in Splunk Observability Cloud, we have these things called detectors, which measure thresholds of things. And then each detector can send off multiple types of alerts, which is critical, major, minor, warning info. And it's really nice to see it all on the homepage to see which one you want to focus on. And you can hover over it and see right now, we have 15 major alerts that have been there for about 24 hours. That's something that we can focus on. And finally, one of our newest additions to the homepage is the AI assistant right here. This is incredibly helpful, especially for new users of Observability Cloud and asking very bare minimum questions like why is this bar red, or why is this alert triggering, or even like I'm stuck, I don't know how to troubleshoot XYZ. And this AI system will help walk you through, tailored to this specific Splunk Observability Cloud page, on how to get down to your incident and the root of it. So this is very cool. We're not going to go through it today in the workshop, but I just wanted to point it out as something that you can definitely use and refer to as we're walking through the lab guide. Okay, so let's start with our first exercise, which is just some basic housekeeping. So like I mentioned, make sure you're in the observability of Marilorg. You can select your theme from here. I'm more of a dark theme person because I have sensitive eyes. So if you prefer light theme, go ahead and do that. Whatever helps you find your incident root causes. And right above here is a button for logout. Don't do that as of now, but That's where you do to log out and log into something else. If you have used Splunk Observability before, you might be in a different organization, so don't be alarmed if you see multiple. Just make sure you're in the Observability Workshop Amera one. And finally, there is a question mark icon here where you can tap on it for various help. Your interface probably looks different than mine in that you have a panel on top that gives you help for getting started, and that panel exists for essentially all these features as this is probably your first time going through it. So if you want to keep it on, you can. If you don't want to, you can just tap on this and you can turn it off or turn it on here. I'm gonna turn this one off here just to keep it consistent. So that's up to you if you want to keep that there or not, but I turn mine off for now. So next we're going to go to section 3.2 of the UI quick tour, which is real user monitoring. And to get there, it's digital experience. And you tap on overview. So let me give you a quick lowdown of what is RUM, or real user monitoring. So Splunk RUM is the industry's only end-to-end no-sample RUM solution, providing visibility into the full user experience of every web and mobile session to uniquely combine all front-end traces with back-end metrics, traces and logs as they happen. IT operations and engineering teams can quickly scope, prioritize, and isolate errors, measure how performance impacts real users, and optimize end user experiences by correlating performance metrics alongside video reconstructions of all user interactions. Some of the really important features they have is full user session analysis. There are streaming analytics that capture full user sessions from single and multi-page apps, measuring the customer impact of every resource, image, route change, and API call. You're able to correlate issues faster with infinite cardinality and full transaction analysis to help you pinpoint and correlate issues faster across complex distributed systems. You can isolate latency and errors by easily identifying errors and poor performance for each code change and deployment. And then through these built-in interfaces, you can measure how content, images, and third-party dependencies impact your customers. You can benchmark and improve page performance by leveraging core web vitals such as these to measure and improve your page load experience, interactivity, and visual stability. You can find and fix impactful JavaScript errors indicated here and easily understand which pages to improve first. You can explore meaningful metrics by instantly visualizing the customer impact with metrics on specific workflows, custom tags, and auto-suggest unindexed tags to quickly find the root cause of issues. And finally, we can optimize end user experience by correlating performance metrics alongside video reconstructions of all user interactions to optimize end user experiences. So now let's explore the real user monitoring overview page. So here is, I guess when you first enter, I'm not exactly sure what you see on your end, but ensure that the environment is Splunk4Rookies and today's date, as well as the app right here. It might be the only one you have, but if not, ensure that it's like indicated as here. Otherwise, you get different data. So just to walk through here, number 2, there is a filter plane that I just tapped through here. You can filter by time, environment, apps, and also your source. Right now it's only browser, but we do have a source of mobile as well. And here's also your application summary dashboard of all of the applications that send to RUM data. So a little bit about how this data is gotten in. Splunk always uses the environments tag that is sent as part of the RUM trace to separate data coming in from different environments like production or development. So you can have it all in this one drop down here in this one team. A further separation can be made by the applications tag, and this allows you to distinguish between separate browser mobile applications running in the same environment. Like I mentioned, browser and mobile applications are available here, but for the sake of this demo, we're going to stick with browser. It's easy to screen share and walk through the e-commerce website. So let's do our first exercise with the RUM homepage. I will walk through with you on this one, but we'll take about 3 minutes just to do this exercise, and I'll come back here to continue on to the APM overview. So go ahead and go to 2.1 underneath UI quick tour of the lab guide, and we'll do the exercise on there. Filter RUM and follow a JS error. All right, so now that we explored a bit of the RUM interface, we can now move on to APM. So now we're on section 3 of the UI quick tour for APM overview. And how to get there is APM on the left-hand side and the overview. So here's a quick overview about application performance monitoring. Splunk APM provides a no-sample end-to-end visibility of every service and its dependency to solve problems quicker across monoliths and microservices. Teams can immediately detect problems from new deployments, confidently troubleshoot by scoping and isolating the source of an issue, and optimize service performance by understanding how backend services impact end users and business workflows. Real-time monitoring and alerting, which is indicated right about here. Splunk provides out-of-the-box service dashboards and automatically detects and alerts on red metrics, red meaning rate, error, and duration, when there is a sudden change. There are dynamic telemetry maps. Splunk EPM usually visualizes service performance in modern production environments in real time. And with end-to-end visibility of a service performance from infrastructure, applications, end users, and all dependencies that helps quickly scope new issues and troubleshoot more effectively. There are intelligent tagging and analysis. We'll get to that soon when we get to Tag Spotlight. But you can view all tags from your business, infrastructure, and applications in one place to easily compare new trends in latency or errors to their specific tag values. There's AI-directed troubleshooting and that identifies the most impactful issues. Beyond the spotlight or the AI assistant built in here, we'll see later in a trace waterfall, Splunk helping us out there to connect various paths. Instead of manually digging through individual dashboards, you can now isolate problems more effectively using AI. And there's complete distributed tracing analyses for every transaction. And by identifying problems in your cloud native environment more effectively, Splunk distributed tracing visualizes and correlates every transaction from the backend and front end in context with your infrastructure, business workflows, and applications. And there is full stack correlation. With this Splunk Ollie, EPM links traces, metrics, logs, and profiling together to easily understand the performance of every component and its dependency across your stack. And finally, something new we have is database monitoring. It easily identifies how slow and high execution queries from SQL and NoSQL databases impact your services, endpoints, and business workloads. There's no instrumentation required. We won't be going to database monitoring today as we don't have the time capacity for that, but that is one of our newest features. It is incredibly helpful in terms of monitoring in our services. So moving on to 3.1 APM homepage. So looking at the homepage, there's a couple of components. The first one is your APM overview pane. So right here, you can close and open it as needed. It shows real-time metrics for your top services and your top business workflows. I think we now call them business transactions. There's also a functions pane on your right-hand side here. I will go into more detail for tag, spotlight, service map, and traces, but it just provides a deeper analysis for query performance and code profiling. The APM overview pane provides a high-level view of the health of your application. It includes a summary of the services, latency, and errors in your application. It also includes a list of the top services by error rate and the top business workflows by error rate, given a start-to-finish journey of the collection of traces. To differentiate between multiplications, we use environments and teams. So if you tap here, ensure that all the 4 rookies in the today's date environment is selected. And like I mentioned, this all the 4 rookies workshop, test, or app name will occur frequently throughout this lab guide. So now I'll do a quick exercise for APM called Filter APM to Your Workshop. So we're going to verify that the time window we set is the last 15 minutes. Then we're going to change this to all the 4 rookies in the drop-down box. Something that we can conclude from the top services by error rate. So looking at this chart right here, we can hover and see at various points of time the values that are changing right here. Purple is payment service. It looks like it has the most amount of spikes, and we see the data loading real time, but this one for sure has the most amount of errors, sometimes at 100%, as indicated here. So we can conclude that there's something fishy going on with payment service, and that's something we probably have to debug from Online Boutique. All right, now we're moving on to section 4 of the UI Quick Tour Log Observer Overview. And to get there, you go to Logs, you just tap on Logs Explorer. So Log Observer Connect should look very familiar if you have used Splunk Enterprise before or Splunk Cloud. It allows you to seamlessly bring in the same log data from your Splunk platform into an intuitive no-code interface designed to help you find and fix problems quickly. You can easily perform log-based analysis and seamlessly correlate your logs with Splunk infrastructure monitorings, real-time metrics, and Splunk APM traces in one place. This provides end-to-end visibility by combining the powerful logging capabilities of Splunk platform with Splunk Observability Cloud traces and real-time metrics for deeper insights and more context of your hybrid environment. You can perform quick and easy log-based investigations by reusing logs already ingested in Splunk Cloud Platform and Enterprise in a simplified and intuitive interface with customizable and out-of-the-box dashboards. For this demo, we're not going to write any SPL, which is the Splunk processing language, but there is capabilities for simple queries in Splunk Ollie to write SPL. It's just not enabled yet for this demo, but in the future, you'll see we'll have the capability. We're able to achieve higher economies of scale and operational efficiency by centralizing log management across teams, breaking down data and team silos, and getting better overall support. So looks very familiar to Splunk Enterprise, including things like interesting fields on the right-hand panel. Moving on to section 4.1 of the UI Quick Tour. Let's go over a quick overview of the main page. So we have a filter bar located up here, which is a very similar time filter, as well as some saved queries that you can apply. It's basically SPL, but they made it into a more UI-friendly interface. And it's also the logs table here. You can filter through and tap on them so you can get more information about each log, and this should look very similar to Splunk Enterprise as well. And finally, we have the fields playing on the right-hand side. These are all the interesting fields that Splunk has picked out intelligently. We can click on the caret there and uh, see more values that show through and explore all values. For a bit of nomenclature, if you're not familiar with Splunk Enterprise, so generally in Splunk, an index, which is something like this here, is a designated place where your data is stored. It's like a folder or container for your data. Data within a Splunk index is organized and structured in a way that makes it easy to search and analyze. Different indexes can be created to store specific types of data. For example, you might have one index for web server logs, another for application logs, and so on. So in a, I guess, real life scenario, you can have multiple indices you can choose from. And then, oh yeah, actually right here. And you can select from here what you want to look at. I think actually this should be Splunk4Rookies workshop. Hopefully that is correct there. And then we can, yeah, run search just to sort that. So now let us do a quick exercise. Oh, actually, this doesn't look right either. Maybe it is arcade. I'm just gonna apply both. We should get the correct logs regardless. So let's do a quick search exercise on 4.1 of the UI Quick Tour. It's called Filter Log Observer to Visa Transactions. So let's take about 5 minutes to go through this, and I'm going to be doing it with you on the screen so you can follow along if needed. Then we're going to essentially filter out from all this mess of logs the Visa transactions from here. If you guys see this banner up here for search queued, it just means a lot of people right now, like all of you attendees, are probably searching, which is causing some real time delay on the Log Observer Connect page. So if you see this, it's not your fault. We'll just have to wait a little bit longer for results to show up. Okay, so since a lot of us are having a lot of real-time log searches and it's not showing the logs that we want, we're going to move on to section 5 of UI Quick Tour Synthetics Overview. Um, this is a real life scenario you enter when you have a lot of devs um, on logs here. But synthetics is located in digital experience, and you can tap here. Oh, yeah, now I finally loaded on synthetic tests. So a little bit about synthetics. So Splunk Synthetic Monitoring provides visibility across URLs, APIs, and critical web services to solve problems faster. IT operations and engineering teams can easily detect, alert, and prioritize issues, simulate multi-step user journeys, measure business impact from new code deployments, and optimize web performance with guided step-by-step recommendations to ensure better digital experiences. Some of their great aspects are it ensures availability. If you click on create new test here, these are the different types of synthetic tests that we can create that proactively monitor and alert on the health and availability of critical services, URLs, and APIs with customizable browser tests to simulate multi-step workflows that make up the user experience. It can also improve metrics. Core Web Vitals and modern performance metrics allow users to view all their performance defects in one place, measure and improve page load, interactivity, visual stability, and find and fix JavaScript errors to improve page performance. It also has front end to back end visibility. There are integrations with all of the aforementioned features here, APM, IM, and on-call, SESI, which you may have heard of, is our alerting systems to help teams view endpoint uptime during backend services, the underlying infrastructure, and within their incident response coordination so they can troubleshoot across their entire environment in a single UI. You can also detect and alert um, by monitoring and simulate end user experiences to detect, communicate, and resolve issues for APIs, service endpoints, and critical business transactions before they impact customers. This also helps measure business performance by easily defining multi-step user flows for key business transactions and start recording and then testing your critical user journeys in minutes. These also track and report SLAs and SLOs for uptime and performance. And finally, one of the most useful features is film strips and video playback. You're able to view screen recordings, film strips, and screenshots along with modern performance scores, competitive benchmarking, and metrics to visualize artificial end user experiences. You can optimize how fast you deliver visual content, improve page stability and interactivity to deploy better digital experiences. So moving on to section 5.1 of the synthetics homepage. Uh, One thing to note is the filters here. There are different test types. As I mentioned, there's about 5. We'll probably focus on browser for this demo as we're monitoring an e-commerce application. There's also different locations um, that you can ping from to test the duration of a request from that area. And each run comes with a different status, so you're able to see all your failed ones at once and attempt to mediate them. Right. So let's continue our tour. We'll take a look at our workshop's automatic browser test. So if you go into the name here, we're going to search by our workshop name, which is Observability, or O11. And we're going to go to this one right here, Observability, and then the today's date, which we're going to tap on that. So this is a workshop browser test for this online boutique website, and it just walks through a simple checkout. Uh, so we see here that the first pane will show the performance of your site for the last day, 8 days, and 30 days. And these uptime trends are also very useful to see across if your ports or APIs are degrading or any way. We're going to look at the performance KPI drop down here. And if we click on this, you're able to see the run duration from different locations. And right now they seem about similar, except from London here. If you want to narrow down a bit more, we can go from -4 hours to the last hour. So here we're able to see a scatter plot of things. I believe the X's here indicate that the test has failed. But this is really useful to see the different types of durations and if you're matching your performance KPIs for your specific synthetic test. All right, so that is the basics of synthetics. We're now moved to section 6 of the UI Quick Tour infrastructure overview. To get there, it's simply go to the left-hand side, infrastructure, and tap on overview. So Splunk IM, or infrastructure monitoring, is a market-leading monitoring observability service for hybrid cloud environments. It's built on patented streaming architecture, and it provides a real-time solution for engineering teams to visualize and analyze performance across infrastructure, services, and applications in a fraction of time with greater accuracy than traditional solutions. Something that's really useful is on the left-hand panel, you're able to tap on different infrastructures that you have, whether it's host or Kubernetes or GCP. And each of these link to a built-in automatic out-of-the-box dashboard for you to use and check out. There's about 300 plus easy to use out-of-the-box content. Right now, we only show a fraction because this demo environment only has so many infrastructure instrumented. With all of these, there is attached some alerts and detectors, which we'll show later, that you can see from these dashboards whether an alert has been triggered or not. You're able to view the data and go investigate it. And finally, what's nice is there's a function called metrics pipeline management that controls, which is located here, that controls metrics volume at the point of ingest without re-instrumentation of a set of aggregation and data dropping rules to store and analyze only the needed data. This also helps you save money by archiving the metrics that you don't need, and infrastructure overview will help narrow down which metrics that you're interested in. All right, whoops. So I clicked on it by accident. This will be an example of a out-of-the-box dashboard for RDS once it's instrumented. All these descriptions and boxes and panels is what Splunk determines to be quite useful for you. And you can edit and clone these as needed for your own usage. All right, so let's go to number 4, shopping at the online boutique. At this point, we're going to now take about a 10-minute break before we start troubleshooting and finding the root cause analysis for online boutique. But during your 10-minute break, if you can go access this website on Splunk4Rookies.show and start adding things into your cart and checking out. Do a couple of these. And in each time you check out, which is at this place order here, I'd like for you to save the the order ID that comes out. I was trying to check out. We see real time is kind of lagging. So copy and paste and save this somewhere on your desktop. You can use what I have on the screen or your own, but I recommend doing your own just so you can be familiar with what you put in the cart and you're able to see it real time in Splunk Ollie. So we'll come back at 1:10 EST time and we'll continue with section 5 of Splunk Rum. Okay. Have a good break, everyone. We'll be back at 1:10 EST time. Hello everyone, welcome back. I hope you all generated your own confirmation ID. Otherwise, you can take the one off the screen too. Well, now get started with the fun part, which is debugging using this confirmation ID, why that checkout process was so slow. And we'll find the root cause of it using all the tools that we just went and did an overview of. So in the lab guide, we're going to be on section 5, Splunk Rum. All right, let's go back to our interface. I'll be my camera off for now until the very end, as I think you guys have saw my face enough. But I'm right here. You hear my voice. All right, so we're gonna do a bit of role play because all you guys have different types of roles that you're in: backend, front end, SRE engineers. So here you're going to play a front end engineer or an SRE that's tasked to do the first triage of a performance issue. You've been asked to investigate a potential customer satisfaction issue with the online boutique application. So here we're going to examine the real user data that has been provided by the telemetry received from all participants' browser sessions. The goal is to find a browser session that performed poorly and begin the troubleshooting process. The first thing we're going to go is the Run dashboard. So if you remember, we go to Digital Experience and tap on Overview. We're going to select Splunk4Rookies store here and ensure this is just the exercise now on 5.1 of the lab guide. Filter run to your workshop. So we're going to select last 15 minutes. And the environment is going to be Splunk4Rookies. App is also Splunk4Rookies. And the source will be browser here. Okay, so it should look something like this. Here is a out-of-the-box dashboard view that's built out for all of our page views, our route change duration from top to bottom. There's all of our web vitals of LCP, CLS, IMP located here. It's all extremely important to ensure that our website is functioning to the user's perspective. So let's do a bit of exploring and click through UX metrics, front-end health, back-end health, and custom workflows to see how our online boutique website is doing. And do a bit of like exploring here, hovering over some of our network requests that are spiking. Images, looks like this checkout call here is at a really high spike in the last 15 minutes. Same thing here for our time to first byte. So in our custom workflows tab, we see that it's the custom workflow duration that shows our latency spikes. Looks like, let me see, biggest one is our city bike. Add to cart is number 2, and then the rest are just various items. So now let's move on to tag spotlight. So we're going to stay on this custom workflows tab here and go to the chart. We're going to click on see all underneath. This is the exercise, open the custom event latency chart on 5.2 of the lab guide. And it takes us to tag spotlight here. So all of these tags here are also straight out of the box. You can add your own custom tags as well that show up here. But for now, this is what you already have, which is excellent because it can help you get pretty far already. So here you're presented with all the tags associated with the run data. Tags are key value pairs that are used to identify data. In this case, the tags are automatically generated by the OTel or OpenTelemetry instrumentation. The tags are used to filter the data and to create the charts and tables. The tag spotlight view allows you to drill down into a specific user session. So let's take about 3 minutes to do the exercise filter to slow placeholder transactions. And I'll do it with you on the screen as well. Oh, and for some syntax context, when the instructions say custom event name chart, it actually means the custom workflow name, which will be this panel right here. And for the final bullet point in filter to slow placeholder transactions, it's meaning to say click on the gear icon above the table. The gear picture did not render correctly. So you would click on something like this and you can select your city from there. All right, so you've gotten a page that looks like this. We'll see a pretty big spike here, P99 and 9.9 minutes, and that we have the highest duration as the first entry of the session IDs. So now we have a user session table that is sorted by the longest duration descending and includes the cities of all the users that have been shopping on this site. We can apply more filters to narrow down the data. But for now, this is good. For me, it's Paris, the longest duration. Move on to section 5.3 of session replay. So a session is a collection of traces that correspond to the actions a single user takes when interacting with an application. By default, a session lasts until 15 minutes have passed from the last event captured in the session. The maximum session duration is 4 hours. So here we're going to open up the longest session by going to here, the session ID, and we'll tap on that. And this will take us to the session view. Your replay might be like tiny like this. So if you want to open it, just tap on that button, replay. And it'll load an interface like that. So we can play this. And this shows you exactly what the user saw. If you have redaction rules incorporated, it will redact some pictures and useful info on there. But you see here, it's essentially a user loading items into a cart and pressing checkout. And when they're trying to check out, there is a really, really long delay. You can also change your playback speed down here and pause the replay if that's something of interest to you. You can also see that mouse movements are captured, and that's useful to see where the user is focusing their attention. In that case, we saw that the user was really focused on the checkout button, probably like either tapping it over and over again or something because it was lagging. Let's move on to 5.4, user sessions. We're going to find the APM jump off plate. So we're going to close the RUM session replay by tapping there, and we're going to scroll down. So this is a really useful like trace waterfall of all the network requests that happen, their duration, and then also their HTTP code. And you can go as long as needed. Each one of these entries here is called a span. So if you look at some of the length of these spans, it's not great, really long to place order. So we're going to scroll down until we come to one that says /cart/checkout. It might be the last entry on your page. This the final call it makes after loading all these pictures and adding to cart. And what's really useful about Splunk is if there is data that occurs across these various tools, they will provide a hyperlink that goes right to it. So maybe in APM, there'll be a RUM hyperlink, and then in IAM, there will be a synthetics hyperlink. So we see here, if we hover over it, it gives more information on the performance summary. Like, the application took that long. It was this specific user ID that took the longest, and then the front end call as well as a trace ID. So already from here, we can troubleshoot more deeply and quickly, which is incredibly useful. So if we hover over this, we're going to click underneath the workflow name, which is front end/cart. This will take us, oh, that happens. Yes, that happens. We're going to refresh. Okay, I guess a lot of people clicked it, which is great because that means you're all following along. This will now take us to the APM tool. And this just shows the end-to-end monitoring of a Splunk. So now we're going to move on to the APM side of things. This is section 6 of the lab guide. We're now going to switch personas because you're done being a front-end developer and now you have found your fellow back-end developer sister team to tell them that there's something wrong with that end. It's not just a front end. So now you're a backend developer and you've been called in to help investigate an issue found by the SRE. The SRE has identified a poor user experience and has asked you to investigate the issue. So now we're going to discover the power of full end-to-end visibility by jumping from a RUM trace, which we were just at, to an APM trace right here on the back end. And all the services are sending telemetry, which is traces and spans that Splunk Ollie Cloud can visualize, analyze, and use to detect anomalies and errors. RUM and APM are two sides of the same coin. RUM is the client-side view of the application, and APM is the server-side view. In this section, we'll use APM to drill down and identify where the problem is. So let's go to section 6.1, a bit of exploration. So the APM service map displays the dependencies and connections among your instrumented and inferred services in APM. This map is dynamically generated based on your selections in the time range, environment, workflows, service, and tag filters. When we click on the APM link in the waterfall, filters were automatically added to the service map to show that the services were involved in that workflow name. In this case specifically, is the front end cart, checkout, transaction. You can see the services involved in the workflow in the service map. In the side pane under business workflow, which should be here. Let me click on this business workflow. The charts for the selected workflow are displayed. The service map and business workflow charts are synchronized. And then when you select the service in the service map, the charts on the business workflow pane are updated to show the metrics for the selected service. So I think before it was this was selected, and you can see the call from there. And then if I click on the service, it shows a breakdown of service requests and errors for that specific payment service. The Splunk APM also provides service-centric views to help you see problems occurring in real time and quickly determine whether the problem is associated with a service, a specific endpoint, or the underlying infrastructure. Let's have a closer look. So on the right-hand side, if you've already clicked on payment service, there is a payment service here highlighted in blue. If I click on that, this takes us to a out-of-the-box generated dashboard for that specific service. And it's really useful because all of this is automatically instrumented. We're going to go to section 6.2 for APM service view. So as service owners, you can see the service view in Splunk APM as a complete view of your service health in a single pane of glass. The service view includes a service level indicator, SLI, for availability, dependencies, request error, duration, runtime metrics, and infrastructure metrics as located here. You can also quickly navigate to code profiling and memory profiling for your service from the service view. So looking at all this data here, let's do, let me see. Well, I guess I just did it. Well, I just did exercise Y in the time frame and explore the dashboards, but I'm happy to explain it again. So let's go to the time box, and we're going to change it to the last 1 hour so we can see more data. And it's nice here that we see the success rate is 20%. That's something to be aware of. This is our basic service map. It looks like Buttercup Payments is not really being called too much, or is trying to, but there's no errors. And then I think the root cause error is right here. If you need a legend for this, hold on, is that it? No, there was a legend. Well, on the previous page for service map, a legend shows that the bigger the service, the more requests are sent, and as well as the bigger the red circle, the more errors there are. So these charts are really helpful in identifying performance issues. And if we scroll down and we go to infrastructure metrics, and this again shows Splunk Ollie's advantages in end-to-end fidelity because this is now getting more close to the hardware. We can see the different metrics for host and pod. Like let's say a CPU is running at 100% or more, that could be one of the underlying issues to the service tabbing out. But right here, it seems like the infrastructure is pretty healthy given the usage. Although this one here is 100%. That could be something that's worthy to note. Runtime metrics are not available as profiling data is not available for services written in Node.js, which this one is written in Node.js. So now let's go back to the Explorer view. I'm tapping on this twice. So if I hover over this, I guess that doesn't exist. Well, let me see if it hovers. Okay, for some reason I'm not able to see the hover when I put my mouse on it. Um, but you can see it on the right hand pane anyway with service requests and depends latency, in that it looks like it's almost 100% errors given the pink and then the total number of requests, um, in that there is really high spikes of latency at the P90 level. That's happening quite often. So we need to understand if there is a pattern to this error rate. And now we have a handy tool for that called Tag Spotlight, which we just touched on before. So now we're moving on to section 6.3, APM Tag Spotlight. So staying on this right-hand pane, we're going to scroll down and tap on Tag Spotlight right here with Payment Service selected, so that all the tags here are associated with Payment Service. Here you go. So this should look very familiar to our overview, but now it's specific to Payment Service. And once in Tag Spotlight, we're going to ensure that the toggle Show Tags with no values are off. So you can tap on this toggle right here, and you can tap on this thing here. It just keeps it clear because not all the tags are populated given a certain service. You just have a lot of empty boxes if that one is checked. So the views in Tag Spotlight are configurable for both the chart and the cards. The view defaults to requests and errors as indicated right here. It's also possible to configure which tag metrics are displayed in the cards, as indicated right here by toggling them. So looking at this couple of cards here, which card exposes the tag that identifies what the problem is? All right, so we're looking at this color key. So pink is error, purple is requests. All right, so I think it's version. I think version might be the issue here, considering that version 350.10 is at literally 100% error rate, and then 350.9 is doing fine. And since the rest of the cards here have very similar profiles of a large amount of pink error and less requests and very little requests that are successful, it seems like these are not indicators of a root cause error. So we're going to remember that version 350.10. So next, let's go to APM service breakdown on section 6.4. So going back to the service map. And we're going to select payment service here. That's why the map looks a lot smaller than before. We're going to tap on this and click on this filter here called breakdown. Let me see. Let's take actually maybe about 3 minutes to do this exercise, breakdown by tenant level for payment service. And I'll do it with you on the screen. All right, so what can we conclude from what we are seeing? Well, we broke down the payment service into different tenants, and each tenant into their various versions. We speculated maybe tenant was causing the issues, but when we broke them down further, it looks like across the board, regardless of gold, silver, or bronze, it's always version 350.10 that has the most amount of errors. And this is the legend that I was referring to on the bottom left-hand corner. If you tap on it, you're able to see here error rate. The root error rate is proportional to the amount of requests coming in, as well as each of these size of the dashes and connections indicate latency. That's something good to know in case you have trouble interpreting the service map. So these span tags here are a very powerful feature. It allows you to see how your services are performing for different customers, versions, regions, etc. In this exercise, we determined that 350.10 of payment service is causing problems for all our customers. Next, we'll drill down into a trace to see what is going on. So we'll go on to section 6.5, an APM trace analyzer. As Splunk APM provides a no sample end-to-end visibility of every service, Splunk APM captures every trace. For this workshop, the order confirmation ID is available as a tag. That means we can use this to search for the exact trace of the poor user experience you encountered earlier in the workshop. Splunk Ollie Cloud provides several tools for exploring application monitoring data. Trace Analyzer is suited to scenarios where you have high cardinality, high granularity searches, and explorations to research unknown or new issues. So let's open up the Trace Analyzer. We're going to click on the outer box of payment services and go to the right-hand panel and click on Traces. So this will take us to the Trace Analyzer tool mentioned before. Actually, let's not set the time range to last 15 minutes. I'm actually thinking maybe the last hour because it's within the last hour we had the order confirmation generated. Oh, and this cannot not do it. All right, let's try again. All right, here we go. And we're going to ensure the sample rate is set to 1:1 for the highest granularity. The trace and error count view shows the total traces and traces with errors in a stacked bar chart. You can use your mouse to select a specific period within the available time frame. You can do that by going like this, and it will eventually show those amount of traces. But for now, we're just going to show them all. And in this drop-down menu, we also have trace duration. So I'll tap on that as that's something that we're really interested in terms of latency and lagging. So the trace duration view shows a heat map of traces by duration. And the heat map represents 3 dimensions of data: time on the x-axis, trace duration on the y-axis, and the traces per second are represented by these heat map shades as indicated right here. And it looks like I lost some darker ones over here. So now we're going to do this exercise, compare error traces over an hour. The confirmation ID that you got from maybe 40 minutes ago, have that handy as we're going to find that trace specific to that one. So let's take about 5 minutes to complete exercise, compare error traces over an hour. Okay, I hope everyone has exactly one trace showing up for their order ID. If there's more, you must have more than one order ID. So we're going to click on this trace ID. A benefit to viewing this trace is that this trace will be accessible for up to 13 months. So this will allow developers to come back to this issue at a later stage and still view this trace for an example. So let's tap on that. Moving on to 6.6 APM waterfall. So we arrived at the trace waterfall from the trace analyzer. A trace is a collection of spans that share the same trace ID, representing a unique transaction handled by your application and its constituent services. Each span, which is indicated by one of these colored blocks, captures a single operation. Splunk EPM considers a span to be an error span if the operation that the span captures results in an error. And they will color code it with something red, like this one, like shipping service. So let's open one of the failing spans. We're going to click the exclamation point next to the slash charge workplace or workflow transaction. And that would be here for me. You might have to search for it a bit. What's really nice is the trace view automatically shows which spans to narrow into by these exclamation points. So we're going to click on this. Okay, it's a big click. Okay. There you go. And a panel will open up on the right-hand side called Span Properties, and this will show all the tags, the process, and more metadata details that will be useful in your debugging. So looking at the error message and the version, which will be located in the tags here, we see something like invalid request, error, 401 status code, error, invalid request, in the version, which is 350.10, exactly as we saw in the trace analyzer. So now that we've identified the version of the payment service that's causing the issue, let's see if we can find out more information about the error. And that's where related logs come in. Related content relies on specific metadata that allow APM, infrastructure monitoring, and log observer to pass filters around in Ali Cloud. For related logs to work, you'll need a bunch of metadata in your logs, which is not important for this workshop, but it just shows how we can get this panel to show up. At the very bottom of the trace waterfall, we're going to click on here, and this is the related logs view that they mentioned. And then we will click on this log here that will open the logs for a complete trace in Log Observer. So let's tap on there. Okay. So now that we have reached Log Observer, we're going to take our second break of the session, and we'll do about 10 minutes and return at, we can do, yeah, maybe 15 minutes. We can return at 2 o'clock at EST time. So a break now, and we'll turn back at 2 p.m. EST time. Okay, welcome back, everyone. We're going to get started with section 7 of the lab guide, Splunk Log Observer, and we'll be in the overview section. So on your screen, you should be seeing the logs section highlighted with logs Explorer checkmark here. And in terms of persona, we're going to remain in our backend developer role, and we're going to inspect the logs from our application to determine the root cause of the issue. As you can see here, a lot of the filters carried over from our APM view, which is really nice, and you don't have to replicate that. Using the content related to APM trace logs, we'll now use Observer to drill down further. And from the previous screen, we saw that related content located at the bottom of somewhere, okay, which is not there right now, is a powerful feature that allows you to jump from one component to another and is available for metrics, traces, and logs. So going up to log filtering of section 7, Log Observer can be used in multiple ways. You can use the Log Observer no-code interface to search for specific entries in the logs. This section, however, assumes you arrived at Log Observer from a trace in APM using the related content link. The advantage of this, as it was with the link between RUM and APM, is that you're looking at your logs within the context of your previous actions. In this case, the context is the time frame, which matches that of the trace, and the filter, which is set to the trace ID. This view will include all the log lines from all applications or services that participated in the backend transaction started by the end user interaction with the online boutique store. Even in a small application such as our online boutique, the sheer amount of logs found can make it hard to see the specific log lines that matter to the actual incident we are investigating. We'll start on exercise in 7.1, filter to error logs. Let's take about 2 minutes to do so, and I will follow along here too. Okay, that was a short exercise. You should see the logs table has reduced to a much smaller amount of just error logs associated with that specific trace. So now we're going to look at these log entries in detail in 7.2 of the lab guide. Before we look at the specific log line, let's quickly recap what we have done so far and why we are here based on the 3 pillars of observability. Metrics, do I have a problem? Traces, where is that problem? And logs, what is the problem? Using metrics, we identify we have a problem with our application. This is obvious from the error rate in the service dashboards, as it was higher than it should be. Using traces and span tags, we have found where the problem is. The payment service comprises of 2 versions, 350.9 and 350.10, and the error rate was 100% for 350.10. We did see that the error from the payment service 350.10 caused multiple retries and a long delay in the response back from the online boutique checkout. From the trace, using the power of related content, we arrived at the log entries for the failing payment service version, and now we can determine what the problem is. So we're going to click on error entry in the log table, and we see it's the host name is payment service. And we see a message here that says failed payment processing through Buttercup Payments invalid API token. So if I was a backend developer and I needed someone to fix it, I would probably tell the dev team that they need to rotate the API token and refresh it so that the payment processing can go through to Buttercup Payments. And there we go. We found the log that we needed in a couple of clicks. All right, so congratulations, you successfully used it to use Splunk Ollie to understand why a poor user experience might happen at the online boutique, and you use our main features of RUM, API, and logs to understand why. We also use Splunk's intelligent tagging and analysis with Tag Spotlight to detect patterns in the application's behavior and to use the full stack correlation power of related content to quickly move between these different components while keeping in context of the issue. So now we're going to move to the next part of the workshop, which is from problem finding mode into mitigation, prevention, and process improvement mode, which means a ton of dashboards. So next we're going to create log charts and a custom dashboards. Section 7.3 log timeline chart. Once you have a specific view and log observer, it's very useful to be able to use that view in a dashboard to help in the future with reducing the time to detect or resolve issues. As part of the workshop, we will create an example custom dashboard that we will use in these charts. Let's look at the log timeline chart. The log timeline chart is used for visualizing log messages over time. It is a great way to see the frequency of log messages and to identify patterns. It's also a great way to see the distribution of log messages across your environment. And these charts can be saved to a custom dashboard. So we're going to stick with this interface here, or we're going to turn this into a useful panel on on our first dashboard. So let's take about 5 minutes to create our first log timeline panel, and then also our first custom service health dashboard. And I'll follow along here. Instead of SF service, we'll be using the field service.name as a recent update to the UI. Okay, so we've created a log timeline panel for our custom dashboard, and it's saved somewhere safely. Now we're going to create a log view chart in a very similar manner. So this will be section 7.4 log view chart, and we'll go ahead and create in a very similar way from these logs a log view chart, and I'll follow along here. Take about 4 minutes to do this one, as the process is very similar. Okay, hopefully you have a dashboard that looks very similar to this. We're going to enhance it a bit more in the following section. For now, in the next section, we're going to look at Splunk synthetics and see how we can automate the testing of web-based applications. Moving on to section 8 of the lab guide, we're going to change our persona and put our SRE hat back on. You've been asked to set up monitoring for the online boutique store. You need to ensure that the application is available and performing well 24 hours a day, 7 days a week. Wouldn't it be great if we could have 24/7 monitoring of our application and be alerted when there is a problem? That's where synthetics comes in, which is like a sister to ROM. We'll show you a simple test that runs every 1 minute and checks the performance and availability of a typical user journey through the online boutique store. So moving on to the synthetics dashboard of section 8.1 is Splunk Poly Cloud from the main menu. Click on synthetics. And we're going to go there from digital experience. So during our investigation in ROM, we found that there was an issue with the place order transaction. Let's see if we can confirm this from the synthetic test as well. We'll be using the metric first byte time for the fourth page of the test, which is the place orders test. So we're going to select from here the test for our workshop. Again, it's Splunk4Rookies, and there should only be one with the date. And after clicking on it, we're going to go to the performance APIs and set the time picker to the last 1 hour. And then from location, we're going to select page because we're going to go to the place order page. And see here, it's populated with all 5. And then for duration, we're going to select first byte time. All right, so it should look something like this. And looking at the legend, we see that the first byte time for page 4, we can filter down a bit more here. Is, let's see, it has spikes randomly here and there at like 8 seconds, while the rest are in the 500 millisecond section. We're going to select the highest data point for the first byte time on page 4, which will be here. That will take us to the run results for this particular test run, which is really cool that you can directly correlate in that way. So moving on to section 2 of synthetics test detail. Right now we're looking at the result of a single synthetic browser test. This test is split up into business transactions. Think of this as a group of one or more logically related interactions that represent a business critical user flow. So let's take a bit of exploration here. There is a filter here to go to specific pages in your transaction. This has to be labeled beforehand, otherwise the hotel will not be able to pick it up. But here it is labeled for us. Here's a film strip that we can scroll left and right to see screenshots of the performance. A waterfall chart is very similar to Trace Analyzer of all the calls that were made and the various links to it. In a video on the side here where you can play and you can see what the user would have saw if they were watching the synthetics play. And then finally, we have on the right-hand side, browser test metrics, which are very useful to see how long things took to load and the various resources that consume the most amount of time. So by default, Splunk Synthetics provides screenshots and video capture the test. This is useful for debugging issues. You can see, for example, the slow loading of large images, slow rendering of pages, etc., as indicated by these bars here. So let's take about 3 minutes for this exercise on section 8.2 on inspect the test playback. Moving on to section 8.3, synthetics to APM. We're going to select placeholder on top as the synthetic or as a page. And then we're going to scroll down to the view with post checkout as the method. So we're going to open up and observe the metadata section. And with the serving timing header, we're able to correlate that it's the correct test run to a backend trace. And yes, we see that here. This would be the similar trace ID that we saw before. And as we saw in RUM, whenever there is a correlation between different components of Splunk Ollie, they will provide a blue hyperlink that will take you to it. So we're going to click on this APM link right here. And it takes us to our very familiar trace view. So we're going to see if there is more than one payment service error. Although this one doesn't seem to have any errors. Oh, and this is also an indicator you can go back to RUM from APM with these similar hyperlinks. Let me try to find one with an error because this one doesn't seem to have it. Oh, maybe this one. Yeah, it might be this one with a really long waiting period. Let's check that one. Okay, yes, there is an error here for payment service. However, the indicated related logs does not show up here. That happens sometimes in a demo where the things that you want to show up is not there. But at least this still shows that Synthetics can connect to APM and RUM very easily, and then still to logs and infrastructure as needed through the related content. So moving on from that, pretend there was a log here. We're going to move on to a synthetics detector, and that given a synthetic error going off, how can we be alerted? So moving on to section 8.4, given that you can run these tests 24/7, it is an ideal tool to get warned early if your tests are failing or starting to run longer than your agreed SLA, instead of getting informed by social media or uptime websites. So to stop that from happening, let's detect if our test is taking more than 1.1 minutes. So we're going to go back to the synthetic homepage via digital experience and the synthetic tests. We're going to go to the workshop tests here again. And then at the top right-hand corner, there's a button called Create Detector. And now this is how we're going to get alerted if there is an error. So we're going to take about 3 minutes to complete this exercise on section 8.4, create a synthetics detector. For my detector, I wasn't able to get the triangles indicating it passed the trigger threshold, so I adjusted it so that it can be underneath those spikes. And you may have to do it as well if you want to see the triangles that indicates you have passed the trigger threshold. All right, moving on to our final working section, section 9, we're going to create a custom service health dashboards. So our persona is, as the SRE hat suits you, let's keep it on as you've been asked to build a custom service health dashboard for the payment service. The requirement is to display red metrics, which is real-time thing, logs and synthetic test duration results. It is common for development and SRE teams to require a summary of the health of their applications and or services. More often or not, these are displayed on wall-mounted TVs. Splunk Observability Cloud has a perfect solution for this by creating custom dashboards. In this section, we're going to build a service health dashboard we can use to display on Teams monitors or TVs. Let's go to section 9.1 of the lab guide. As we already saved some useful log charts in the dashboard in the log observer exercise, we're going to extend that dashboard. So if you remember the name of that, it was your initials and then service health dashboard. So we're going to return to that. We're going to dashboards here on the left-hand side, and we're going to be taken to our team view. Oh, if you added it recently, you should be able to click on it from this recent view here, and it will show our previously saved dashboard. Why do I have two log views? I don't know, but it's okay. We'll just leave it there. So we're gonna take some time to enhance this dashboard, and I'll give you about 4 minutes to do the exercise. Open your custom dashboard on section 9.1. Okay, so your chart should look something like what you have on the screen. And if not, let's go back to the lab and try again tomorrow. So now we're going to add a custom chart created from scratch that's not from logos or review on section 9.2 of Service Health Dashboard. We'll be creating a custom chart with synthetics. And this is a little bit more involved, but I think this will give you a really great experience of what it's like to create a chart given our metrics available in Splunk Observability Cloud. So we'll take about 5 minutes to do the exercise, add a custom bar chart. Okay, so if you made your screen full screen, this is what it should look like. And there's now a green boundary around the overall test duration. And the green indicates that it's a healthy detector, and it will turn red if it's not. So congratulations, you made your first custom chart as well as custom service health dashboard. So now let's run through a workshop wrap up. Congratulations, you have completed the Splunk4Rookies Observability Cloud Workshop, and you've become familiar with how to use Splunk Quality Cloud to monitor your applications and infrastructure. I forgot to put up a slide. So now that we've wrapped up, a couple of things I want to share. So where can you go today after today's workshop? I know there's a lot of material. There's plenty more out there to guide you and make more custom things. There's documentation located on docs.splunk.com with all of our latest features and walkthroughs on how to instrument everything, including those very niche products like React Native and Oracle Fusion Cloud. We also have Splunk Lantern. This is a little bit more advanced and has step-by-step procedures to instrument your databases and other cloud stacks. Finally, there is training and certification available if you want to have a nice shiny badge on your LinkedIn. You can take online classes, very similar to this one, as well as certification tracks for different roles. And finally, if you go to any of these links, there may be a local Splunk events near you guys called user groups where you can go in person and meet other people who are also enthusiastic about Splunk and get really hands-on with the instructor there as well as with your peers and learn our newest things from those user groups. So thank you everyone for attending. I know in these 3 hours, there's a lot of material shared and a lot of quick walkthroughs. But I hope all these takeaways have been really helpful in terms of choosing Splunk as your observability tool and for your companies. And I look forward to seeing you in future workshops with Splunk. I'll take this time now to answer any questions that we have in the Q&A, now that I have the bandwidth to look at it. Yeah, thank you all for coming.